Welcome to Is It Observable, the YouTube channel providing tutorials on how to observe a given technology. Today's episode we will talk about one of the main popular technology in the cloud native space, and in fact we already started to cover it on the previous episodes. I'm referring to, of course, Kubernetes. So last episode we covered how to collect Kubernetes metrics with the help of Prometheus. Today, in this episode, we will cover how to collect logs from your Kubernetes cluster. We are extending the observability. So let's see what you are going to learn out of this episode. First, the importance of logging. So we need to define what is standardized logging and centralized logging. And because this episode we will use one specific solution called Loki, then we need to define a few concepts. So the Loki's architecture, of course, and Loki will utilize different log collector and processor, forwarder, and the default one is going to be Promtail. Of course, there's a lot of other agents out there, and of course the one that you probably think of is FluentD and FluentBit, but I think they deserve a dedicated episode for that. So last, we will finish with this episode with a tutorial where we will install Loki on our existent Kubernetes cluster that we already deployed in our previous episode with Prometheus in Grafana. And then in the tutorial, we will basically connect Loki to Grafana and build dashboards with the help of LogQL. So let's see the importance of logging. So every developer here has written logs to send debug, info, error information. Logs are so crucial. There are a lot of meaningful information like the time spent in the methods, the stack trace in case of an error. So basically, if you are from the source of the logs, there are so much information we could utilize to understand our system, how our system is behaving, and also be more efficient when we need to troubleshoot. So to be able to take advantage of the log, there are a few things to consider. So first, standardized logging. So what it is. So since ages, we've been writing applications, and those applications was writing logs into files. But there is no standard, so I can have my own application writing on a specific folder or location in my disk or network. And then, if you don't pay attention and you let this application writing logs, then after a while you can run into disk issues.
No, God, please, no!
For sure. And this is somehow something acceptable. So how can we avoid this? There are several options possible. The first one is, okay, let's say I don't want to write in a log. I want to take advantage of those cool agent log collectors and forwarder. Makes sense. But remember, we didn't put any standards, which means if I deploy that, the log collector and forwarder will be in charge of taking the logs from the location where it's stored, process it, and then forward it to a central solution that will store the logs. But again, because we don't have any standard, it would mean that you will have to configure all those endpoints, all those targets where the agent has to scrap the logs from. So it's going to be just annoying to go through all those configurations. So if we don't put any standards, it could be just, time consuming for us. So what are the other options? The other options could be, instead of writing into a file, we could maybe code directly in the application, say, I don't want to write into a file anymore. I want to send it to the storage. to the centralized solution that will store and index my logs. And that makes completely sense. I'm getting rid of one step, in fact. So let's do it. So we take a couple of days, we add some few lines of code in our application, and bam, we got our logs in the right location. Perfect. But there is a disadvantage. You know, there's always someone in your organization that comes in the morning and say, today we don't want to use application A anymore because it's too expensive or it doesn't make sense. We're going to use application B. All right. So the consequence of that is that you have to go through all your code that you already done to change the destination of your logs. Instead of sending to A, you have to send it now to B. So I think that doesn't make sense. It seems very expensive just to manage your logs. So how can we make it more clever? So for that, the best way is to leave our application writing the logs in a standard format. And what is that standard format? If I'm writing a bash in the Linux environment or Unix environment, and I put an echo, then I run my bash script, you will see that in the terminal, in your console, you will see the logs arriving. Those logs, the echo, just has sent the logs to std out. So basically std out has printed out the logs in our terminal. In the container environment, it's the same thing. If I run an application and I just do a system out of my logs, and if you type the command docker logs, then you will see that the logs will come up on your terminal, similar to the bash. So in fact, in the container world, in the Docker world, the Docker runtime takes the logs sent in std out and manage for us. So basically it will take it and write it into a log file. And that file in Docker world is stored in var lib docker. And then inside of that folder, there is a folder called containers. And you will have one individual folder for each of your container. And the name of the folder will be the ID of the container. Which means we know that if we run in containers, then all the logs that you're writing and by using system out, they will be directly pushed to that file. So we have a standard. So pushing the logs in std out is clearly making a standard. So now we know Kubernetes is using containers, which means we know that we could take advantage of that standardization, because if you write our logs and we just send the logs there, boom, we got our files written in the right locations. So we don't have to deal with dozens and thousands of locations to be able to collect those logs. So now it's clear. We know what is standardizing. And now let's see, so centralized logging. So now we know where the logs are located. So we could clearly build a process that will run in each of our nodes and collect those logs. Makes sense? But it doesn't make sense, in fact. There is so many great solutions out there, it doesn't make sense to reinvent the wheel. So why don't we take advantage of components that are named a log, collector, and forwarder. So you see it, you can hear it in the name. You have collector and you have forwarder. So collector is obviously collecting things, but it doesn't do only collecting. It will also transform. Remember, we could write our logs in our own format, so we probably want to transform the logs to make it standard. And we are running in a Kubernetes environment, so we probably want also to add some context details. So like the pod name, the namespace, the node name, and so on. And then we are going to forward that log stream once we have the design information to solution that will be in charge of storing the logs and probably index it. There's a lot of solution out there, and most of them they're using index, like Elasticsearch and Splunk, they're using index. Index are great because it helps you to do a lot of queries on the logs, but it has a consequence. It just consumes more memory. Today, I wanted to have this episode to present a promising solution on the log area called Loki. So Loki is a project built by Grafana Labs. So basically, they wanted to provide to the market a logging solution that will be easy to use, reliable, and performant. We can say that some Prometheus is used for metrics, and Loki will be the Prometheus component for logs. A lot of the people in the community compare Loki to Prometheus, in fact. So you'll see that there is a lot of similarities between Loki and Prometheus. When you deploy Loki, there are several components that will be deployed on your cluster. So first, naturally, you will have the Loki server. So the Loki server is acting like a storage. It will store the logs in a time series database. It's very similar. But you won't index it. So Loki is clearly a data source to store logs. So you're not going to use Loki to visualize your logs. Loki will act like a data source for Grafana. So you will use Grafana to create dashboards with the help of LogQL. So we will briefly introduce LogQL, but it deserves clearly an episode for that. Then, aside of the server, you will have some agents that will be deployed as a daemon set, which means on every of your nodes, you will have pods that will be there to collect your logs. In terms of agents, Loki is pretty much flexible. It supports various of agent collector and forwarders, but the default one is named Promtail. So Promtail, like expected, will collect the logs and forward it back to Loki. There are various forwarders supported by Loki, like I mentioned. The most popular one is FluentD and FluentBit, but today let's focus mainly on Promtail. So let's see Promtail. Promtail is doing several actions when collect logs. So discover the targets having logs. He will attach the labels to the log streams, and then he will push it to Loki that will store the logs. Promtail has a configuration file. It could be config YAML or Promtail. In fact, this configuration file is stored in a config map when you deploy it with the Helm charts. In the configuration file, you will have several things that you will precise. So the service settings, which port is the Promtail listening to. Promtail also exposed an HTTP endpoint. Well, you will be able to push logs to another Promtail or directly to Loki server. You have a health endpoint, and of course, last, very useful, you have a /metrics. So Promtail is naturally exposing metrics in a Prometheus format. So then you could also track the number of bytes exchanged, the stream ingested, the number of active and failed targets, and so on and so forth. Then you also have the client configuration. It specifies how it connects to Loki. Also you have another setting which is important, is the positioning. So what does it mean, positioning? Position is required to make Loki reliable. So basically, when Loki, Promtail, is collecting the various log streams, he marks where it is in his job in a position file. Why? Because if your Promtail crash for some reason, then when Kubernetes will gonna relaunch it, then he will reach out to the position file to figure out what was the last thing he has collected, so then he can resume the work. So you won't have any duplicated log stream stored in Loki. And then you have the scrap config. Scrap config sounds very familiar as well. So scrap config will precise jobs that will be in charge of collecting the logs. Then you have a relabel config that will control what to ingest, what to drop, and what type of metadata you want to add to the log stream. You can also automatically extract data from your logs. For example, if your logs are exposing the time spent in the method or the number of bytes exchanged, whatever type of statistics. then you may want to also extract that type of metrics and expose it in a metric, like Prometheus. Let's see now the configuration of Loki. Loki has also a configuration file stored similar to the Promtail in a config map. The configuration will allow you to specify where to store the data. So you can store it directly on the volume, or you can also store it on a cloud provider if you want. How to configure the queries as well. For example, the timeout of a query, the maxed tail durations, and so on and so forth. When deploying Loki with the Helm charts, all the expected configuration to collect logs from your pods will be there automatically. So, of course, if you need to change the way you want to transform your logs, or if you want to filter to avoid collecting everything, then you will definitely touch the configuration of Promtail and few settings in Loki. But in our example, we don't need it. We want clearly all the logs to then visualize it in Grafana. So now, let's jump into the tutorial. Like every tutorial that we deliver with Is It Observable, you will have it in github.com, an organization called Is It Observable. And within this organization, you will have one repository for each individual episode that we deliver. So here, obviously, it's the episode about Kubernetes and logging with Loki. Everything is described step by step, so you can do it from your own, at your own pace. The only detail here is that we are not going to install a fresh new cluster and redeploy Prometheus and Grafana. We already did that on the previous episode, so let's take advantage of this. So let's jump into, we will start the tutorial from the step where we will have to install Loki on our Kubernetes cluster. To install Loki on our Kubernetes cluster, I would recommend to have a look at grafana.com, the documentation of Loki. There is the details of the Loki's Helm chart, and there is various type of deployment with the Helm charts. You can deploy it Loki by its own, or with Loki and Promtail and Grafana and Prometheus. So basically, pick the installation that makes sense for you. And then you just have to do that. So for us, we're just interested in installing Loki with Promtail. So that will be almost the default one. So let me bring up the terminal, and I'm just going to do a kubectl to show you that we have Prometheus and Grafana installed, like we did on the previous episode. Now let's jump to the step where we are going to basically deploy Loki. So here the first thing I'm going to do, so I already have done it, so I'm going to add the Grafana Loki Helm charts to my repo. It's already been done, so I don't have to do it. Next, I would recommend to do a Helm repo update to make sure that you're always referring to the latest version. And last, we are obviously going to install Loki, and you will see it's going to take a few seconds to do that. And that's it, we have it. So let's do a kubectl get pods. All right, so we can see that we have a Loki server, this is the part related to Loki server, the storage. And then we have a side of that, we have one Promtail pod per node. So in my case, I have 3 nodes. That's why we have 3 pods for the Loki Promtail. Now, I'm just going to display the services. So why? Because I need the exact name of the service. Why do I need that? Because we're gonna basically configure Grafana to connect connect Loki to Grafana as a data source, and they are in the same namespace. So I don't have to utilize anything. I can just put the name of the service. That's great. It simplifies a lot. So let's jump into Grafana. So here is Grafana. I'm already in the configurations of Grafana. As you can see, there's a data source sections, and I'm going to add a new data source. As you can see, there are various categories of data source, and the one we're interested in is in the logging side, and we're going to select Loki here. In terms of, so the default port is 3100, and the endpoint for our Loki server is the name of the service in our cluster, because they are, like I said, Grafana and Loki is located on same namespace, same cluster, so there is no issues to connect both of them. So that's it, Loki 3100. And I will save and test to figure out the data source is pretty well connected, which it is. Now that we have connected Loki to Grafana, let's go to Explore just to look at what we have here. So in Explore, of course, you can see that we have Prometheus and Loki. So let me make sure that you select the Loki data source. There's two dimensions, metric and logs. So if you're just querying the logs, you can stay in logs. And then from the moment you're going to add functions with the logql to basically build a graph out of your logs, then you will have to switch to metrics in the Explorer of Grafana. So the first thing I'm going to do here, so we have a couple of cheat sheets here you can figure out here on how to filter on various jobs and apps and label here. What I'm want to do is I'm interested on collecting the logs related to my product that we have installed on a cluster, which is Hipster Shop. So now I can see all the logs stream arriving here in our screen. There is a lot of errors and std out. Both are collected by default by Loki. Let's say that we are interested to just filter first on have a better filtering based on the label. So let me select one of the log stream that makes sense for me. So this one, and it seems that this log stream comes from the service frontend. So I can also add here, for example, a filter. Say I want to also filter on the app frontend, which I did. I didn't change the settings of Loki, but I could have it in order to basically have a new label to differentiate std out and std error. So I could easily filter here. So I didn't do it, but we could basically change those settings to have a better filtering. Now, if you don't have the labels, you can still do filtering. So here I'm going to add a pipe, like a grep. And if I type equal, it means I'm looking for a log stream containing this character or this string. So here I'm interested in collecting std out. So I'm going to basically say std out. So I'm filtering on this. So if I rerun, so you can see here, he has already identified it, that that those has what I'm looking for. And then if we look at the line, I'm looking the information I'm looking for. It seems because there are a few information about the status code, the response times, the bytes. It's basically, you can see here, it's a severity debug. Here you can see debug here. So let me add as well another filter here. So I'm going to another pipe, and we're going to add debug here. So that will help me to again filter again. So here I only filtering to all the std out having the filtering the severity at the debug level, and then if I want, I can also transform this log stream into JSON, which means all those properties that you see here, for example, http.request.path. If I convert it into JSON, what would happen is that those fields will be considered now like a label, and I can also apply extra filtering on top of that. So if I do JSON like this, you won't see much, in fact, to be honest. But if I had a better filtering, I could also say, all right, so now let's take an example. We have, let's say, http underscore resp underscore status, okay? And we are looking for, let's take one of the line that are looking for, let's say here 500, let's say 500, does that make sense? Equal 500, all right? And if I run that query, then it will filter me to this. So you can see that by this, I was able to take advantage of these functions that will transform that label and add extra filtering on top of that. Once you have done this, There's plenty of functions, and LogQL is it's a big topic, so we're probably going to do an episode dedicated for that. But I can still use, for example, a rate function. So for those who are familiar with Prometheus, you probably know these functions. I need to do a sampling, so I'm going to do like 30 seconds, for example. Now, 30 seconds. And now, once I have this, I want a metric, because the rate's going to bring me a metric, so it's a graph, and I can run that query. Oh, there is an issue. Oh, yes, because I use a JSON here, then basically the conversion could also introduce errors, so you can also have to filter that. So let's remove, just for the sake of the example of showing you how to upload a metric on this, I'm going to remove this filtering on the status and the field. And now you can see, now it's going to count number of log stream per seconds arriving with the filter that I have applied. So the filter is stdout debug and for hipster shop. So here you can see that I didn't have much, but at one certain stage here, I had like a 295 log stream per seconds that has arrived in Grafana. So that could be right. Again, you could be very creative and extract metrics that could be utilized for a dashboard. So now we have that query in Explorer. So then I want to take advantage of that. So I'm going to jump into the previous dashboard that we've built on the previous episodes. And I'm going to add a new panel here. And it's going to basically utilize Loki here again. And I'm going to send that query. Now we have it. And then I could basically use graph here. And if I want, of course, I can customize a bit the display of this graph to add columns or have more precision. So I can maybe put some bars to have more colors. So you can do a lot of things. I mean, it's more a pure Grafana feature here. It's not related necessarily to our interest of bringing back the logs in Grafana. So let's put a name. So debug hipster shop debug stream per second. It's not a super relevant KPI, but now I'd say I'm utilizing it. So as you can see, I didn't have nothing at the beginning because we just freshly deployed Loki, but now we can see that we have a big amount of logs, and I can follow that. Again, this was a pure example, but again, you can by looking at the logs, they are very meaningful information that you could collect. Also, you can figure out how many stack trace and errors or exceptions that you're having just by querying this.
All right, so that's it for today. We learned a couple of things today, everything about logging, what is Loki, and moreover, how to connect Loki with Grafana. We've seen that there are a lot of interesting things we can achieve with LogQL. So we are clearly going to do a dedicated episode to cover those aspects. Alright, so if you enjoyed this video, don't forget to subscribe, to like the video, and stay tuned. There will be soon other episode on Is It Observable. See you soon. Bye.